Hey guys, if you check the email, I've attached the 2018 growth exam. So there's two short answer questions in the Ramsey model. Let's do the Ramsey model. And then we'll also do, on page 2, there is an OLG model. So we'll solve them both. For the Ramsey model, we have a policymaker question. In policymaker question, always remember you don't need the accumulation of resources equation, that A dot, and then do the market clearing condition. We're going to jump directly to the resources in the economy, which is given by this equation kind of in the middle on the bottom. K dot T equals AKT alpha minus delta T minus CT. And if you think about it, it really makes sense. Let's write some stuff down. If you break down that equation, it's quite easy to remember that if you have a policymaker, this part here is just the production function. This is f of k. So the stuff in the economy, k dot, is equal to everything we make minus the stuff we already had that breaks and minus the stuff that we eat. And in this equation we have this 1 minus beta, and that comes from, if you read the problem, it says that there's a price function. It says P of CT is given by CT to the minus beta. And it asks, what does that mean? It means that as the price goes up, that consumption goes down. Okay, so, so the good is a normal good. So let's solve the Hamiltonian. The first order conditions will be the same, so we'll do the first one in this video and the second one in the second. So let's just write the first one is going to be always with respect to consumption, it's going to equal 0. And our goals are to find nu and nu dot. So if we take the derivative with respect to consumption, we get e to the minus rho t divided by ct. This is the first part, and there's no c here. There's only a c inside the natural log, which will be 1 over ct. And we don't need to use the chain rule because we're taking the derivative with respect to c. If we took the derivative with respect to time, since c is a function of time, we would do chain rule and get that c dot, but that's not what we're doing here. Okay, so e to the minus rho t divided by ct, and then we distribute the nu over to this c, and it's negative, so we'll get minus nu ct, and using power rule, 1 minus beta ct, and then we de-increment, so we get minus b, and that's all equal to 0. So now we want to rearrange to solve for nu. Nu ct 1 minus beta ct to the minus beta equals e to the minus rho t divided by ct. And we can write this minus beta as 1 over ct beta, so we'll multiply both sides by ct to the beta. And we will get, whoops, I wrote one too many ct's, I'm sorry. What did I do? This isn't here. Sorry guys. Got a little too excited about all that consumption. We're going to have nu equals e to the minus rho t times ct to the beta minus 1. Because this is beta, this is minus 1, so we get beta minus 1. And then we can also divide by this 1 minus beta, so it's going to be divided by 1 minus beta. And so that is our nu function. I guess that's the shadow price of assets. And then we need to find nu dot. And dots always mean, a dot means you're taking the partial derivative with respect to time. So this is where we're going to get that c dot come out. So nu, we can write it as 1 over 1 minus beta times, and we have two functions of time. This is 1 and this is 1. So let's do them in the other order. We're going to get down a minus 1 minus beta ct to the beta minus 2 times e to the minus rho t, and then to that we will add the ct beta minus 1. Now take the derivative of the second one, which is e, so it stays the same, but chain rule we will get a minus rho. And then we can clean that up a little bit. We have a minus here and a minus over here, so we can factor it out. But otherwise, I think we are good. Let's choose yellow. So our final v dot, oh whoops, we're not good. I forgot to take the chain rule here. When I took the derivative of this, so I spent all that time talking about c and chain rule and time. We did the power rule here, but after we do the power rule, c is itself a function of time. So here we need to add a c dot t. So our final answer will be 1 over 1 minus beta minus 1 over 1 minus beta times 1 minus beta ct to the beta minus 2 dot t e to the minus rho t plus ct to the beta minus 1 e to the minus rho t and rho. And there you go. That is our v dot. So in the next video we will do the second first order condition and then use this v and v dot, or nu and nu dot, to solve for the Euler equation.